Hi, Eric, can you hear me? Can you hear me?
All right, it's my fault. You hear me now?
Sure.
Okay, so that's my fault. I was muted. So I told that Stefano is working for Akamas. So Stefano is based in Italy, Milano. I was just started with the company. So the Akamas is providing a revolutionary software that will auto-tune your systems. It's pretty impressive. If you don't know, go to Akamas websites. You will see that there are a lot of white paper showing the results of the auto-tuning system that they've built. So it's going to be pretty impressive. So Stefano has been in the industry so many years. He's been involved in the CMG conference. I mean, he is pretty very, very skilled engineers. He knows what he's talking about. If you have any questions about how to optimize any systems or how to do capacity planning, I mean, Stefano will be the guy to answer to all. About, like I mentioned, if you move on the cloud, if you, for example, moving on AWS, in EC2 instances, there's lots of different type of instances in terms of CPU, in terms of memory, in terms of. So first of all, you need to pick the right instance, and then depending on the instance that you choose and how your application behaves, the cost of hosting your application could be completely different. So it's important that when you start a journey in the cloud to control your costs. So here, Stefano will help you to control your costs. So Stefano, thanks to be again part of the pack. So you were with us in Chamonix, and here it's your first virtual pack. So welcome on board on the virtual pack, Stefano.
Hi, Eric. Thanks a lot for the introduction. Can you hear me?
All right, so I will reach you out in the next 30, 40 minutes for the Q&A.
Okay, that's great. So thanks a lot for the introduction. You did a pretty great summary, actually. So thanks also to Neotys for organizing the pack and having me here. I'm really excited to give you this talk. So the focus of today for me will be actually on cloud cost and performance, as Eric summarized. So it's pretty evident to everybody, I guess, that the cloud is actually one of the biggest IT trends in our industry that we are seeing today. So lots and lots of organizations are more and more moving to the cloud, and rightly so. So because the cloud is actually providing huge set of benefits over the traditional way of managing data center and the IT. So it's allowing organizations to move faster and faster, deliver business services with higher velocity, cutting cost, being more secure, more performant, and so on. So it's all good, but we have a set of issues actually when we are helping. That we saw when we helped lots of organizations in this kind of movements. Actually, the first thing that organizations start to realize, the very first, is that at the end of the month, you are getting this kind of pretty interesting bill from the cloud providers. So it's typically much higher with respect to what organization typically expected, which is, I would say, the first problem, so the cost problem. And the second problem, which is more, in a way, closer to what we do, is the performance problem. So actually, it's not that easy to assure the end-to-end application performance hosted on the cloud. So there are lots and lots of challenges that we have seen in helping organizations do this kind of movement, and this is basically the focus of my talk. So the problem, what's the problem? Actually, we have one of the fundamental issues that underlie basically both the cost and the performance problem is that the cloud is, today the cloud providers are offering a huge set of services that end user can use to build up their application on the cloud. So it's a pretty fundamental shift and different with respect to the traditional way of managing data centers, where you had your pretty much unique size of servers, you had a specific storage, perhaps you had a storage on a network, you had your x86 servers, you had your higher end servers for the database and so on. So the IT was pretty much static, and that was it because it was designed that way. When you move into the cloud, the picture is totally different. So you have this huge set of services that you can actually pick and choose in order to build your application in the best possible way. By the way, I will be focusing on this talk on actually the infrastructure as a service services. So that does mean basically compute, so virtual machine basically, and the storage. So I'm not going to focus on serverless or database as a service and other stuff. So today, compute and storage are actually the most common services that are deployed on the cloud. And I will be doing lots of examples from major cloud providers like AWS and Google Cloud, but pretty much all we will say is pretty generic. So this is just to start the problem, to present the problem. So this is the kind of offering that is today being offered by AWS. So this is a slide that I got from the latest re:Invent, so their major conference, where they outline this kind of huge portfolio of instances. So instances are virtual machines. So you have today on AWS 175 different instance types, which are different kind of characteristics of the virtual machine that you can choose from for pretty much every worker and business need, as they say. So you have this kind of choice among different kind of hardware processor, for example, from the high-end Intel processor, very power-hungry processor and very fast processor, down to a very power-savvy ARM processor, depending on the need. You may have high memory intensive instances where actually you are, depending on the workload, you may need much more memory with respect to the number of CPUs. So you have to choose, you have the ability to choose different kind of trade-off among CPU and memory. Then you also have, for example, special purpose hardware. That might also mean, for example, special kind of storage devices that are directly attached to the instances, for example, to power most, I would say, power IO angry, storage angry application like high performance databases, or even special purpose networking gears to extract the most performance if you have a networking heavy application. So this is the kind of landscape you have to choose from. By the way, each kind of instance comes with a different size, so you can choose from one CPU up to big monsters of 128 CPUs. So all of that is possible today on the cloud. And of course, besides the performance question, the other thing is what is the cost associated to this kind of possibility of selection. So today the costs actually are very, very wide ranging. So you have pretty much, as you can see, from $3 per month up to almost $20,000 per month based on the kind of instances that you can choose. So we have 5 orders of magnitude. So the cost, if we are not going to choose properly, the cost is going to be very, very big. And this is the first challenge. The other stuff we will be talking on is about the storage. So we mentioned the fact that we will be focusing on compute and storage. On the storage side, the choices are fewer. You can see, again, an example that I took from basically AWS. So today, AWS is offering 4 different types of storage. 2 of them are based on latest generation hardware, which are solid-state disks, and the other 2 are based on traditional mechanical disks. But the way I see storage is still interesting because actually storage is in a way much more difficult to analyze from a performance perspective. This is true also in the data center world. So it's difficult to understand how the storage is behaving, what is the actual utilization, how we can extract, what is the additional capacity that we have on the storage. If you speak about, for example, on the IOPS, storage IOPS that we can still extract from a device. Those are our questions in general, and on the cloud, actually, those kind of problems remain. So how do we properly select the kind of storage volume types is actually still a critical question. And also, again, the cost is related to that, because actually we have seen lots and lots of examples in MP organization where the cost of the storage is going to be the number one item on the cloud base. So actually, if you look at the price per gig per month, it looks pretty low, actually, sorry. But actually, the numbers add up, and it can very quickly become your number one expand on the cloud. The other thing that is interesting to notice is that you are not just paying storage devices based on the amount of storage that you need, so the typical storage capacity in terms of space, but there's also the IOPS part of the equation. So there are specific type of storage, such as the IO1 that you see, the second one that you see here, where you can say to the cloud provider, I want this specific IOPS number to be provisioned, so that I'm really sure that my database can actually extract 20,000 IO per second, and I'm sure that I will always get this kind of performance. And you have this kind of capability on the cloud, which is actually not that easy on the on-prem world. So it's very nice to be able to do that, but of course, again, you have to pay for this kind of capability. So this is another, in a way, variable that you have to consider in this kind of puzzle, where you have to select the best cloud options for your application to perform at best and provide the least cost. So besides, we're talking about the challenges in selecting the instance, so the compute piece, the storage selecting, also the storage piece, but there's another thing that is actually making the picture even more complex, which is the fact that those two worlds are not actually independent, so they are related. So the selection of cloud compute can actually impact the performance of the storage type, the storage volumes that you are going to select. So you can see here the reason for that is due to the fact that the instance, at least on AWS, is being equipped with a dedicated network, basically, towards the EBS, which is the Elastic Block Storage. So it's the storage service offered by AWS. And even this kind of special purpose network that is designed to ensure high performance toward the storage volumes has some kind of bottlenecks. So you can see in this example, on the right, we have a volume which we provision to sustain 6,000 IOPS, so a very high performance volume that we paid on the cloud. And then you can realize that the volume cannot provide all the performance that we purchased due to the fact that we have bottlenecks on the link between the actually virtual machine and the storage. So this is another actually things to consider. By the way, this is not actually easy to monitor also. So you can find this kind of bottlenecks on the product page on the cloud provider, but those are not really exposed also from the monitoring perspective. So this is another challenge to be able to consider this kind of hidden bottlenecks and not being actually hurt by lower performance with respect to what we purchased due to this kind of not so easy to be monitored bottlenecks. So we have seen that we have actually these kind of issues in properly selecting the cloud services. So considering our aim of actually extracting the most performance from our application and actually not wanting to overspend on the cloud, what can we do to actually improve the situation? Actually, there are a couple of existing approaches before we move on to what is the next step in our view. So what are the current approaches? So the first one is actually provided directly by the cloud provider themselves. So you can see an example here that I took from Google Cloud. It's an approach that we can call the model-based approach or resource-based approach. Basically, within the cloud providers themselves, you can find this kind of recommendations. So the cloud provider themselves started to actually provide recommendation to the customer in order to actually help them navigate this kind of complexity and decrease the cost where they are not actually needed, which is, by the way, in itself an interesting concept. So the cloud provider are helping us to actually decrease the cloud bill. The problem with this approach, basically, before the problem, what is this approach? How does it work? Basically, you can see what is doing Google Cloud is basically they are monitoring the infrastructure usage, just like we could do on the data center with the traditional monitoring tools. For example, Google Cloud says that they will be monitoring 8 days of data. And based on that data, they start to analyze the utilization of your resources, basically CPU and memory of the instances. And the usual model-based approach is that if you see the CPU usage, for example, that is consistently low, for example, 20% or less, the cloud provider start recommending you to switch to a smaller instance, for example. And conversely, if they start seeing that you are, in a way, consistently having a high utilization for some resources, for example, CPU or memory, you have lots of peaks, they start recommending you to choose a more pricey and bigger instances. The problem with this approach that we have seen in several occasions is that this approach is completely resource-based. So we are just looking at the infrastructure, we are just looking at the compute layer. Actually, we are totally disregarding what is happening at the application level. So what is happening at end-to-end application performance where we are doing this kind of suggestions, with this kind of deployments, so having bigger instances or smaller instances can actually impact the end-to-end application performance in subtle and in counterintuitive ways. We have seen situations where actually increasing the size, putting more CPUs in the instance actually made no difference to the actual application performance, or in some cases even made the application performance worse. This is due to the fact that, for example, this kind of method totally also disregard what is the application architecture, the application scalability, and also what is what we can. Another thing that we cannot predict is actually the underlying infrastructure and the platform. So, for example, switching to a higher number of CPUs actually on the cloud means that you are going to use a pretty significantly different hardware and hypervisor on the cloud. And so it's not just a matter of adding 2 CPUs to your existing 8 CPUs. You are completely switching the CPU architecture, and sometimes this can have a significant impact on the performance. The other traditional approach, which I would say it's pretty well known to all of us, is, of course, how we can ensure that our performance is good when we do this kind of switching of architecture or switching of different kind of cloud options. The golden rule remains: do your performance testing, of course. So the experimental approach. And it's interesting that AWS itself is putting this statement on their basically EC2 product documentation page, where they actually very clearly state that there is no substitute for measuring your end-to-end application performance. Exactly for the reason that we mentioned before. The recommendations are great because they can help you. If you have lots and lots of instances, you can instantly catch underutilization and start to reasoning about what you can do to save costs. But actually, sometimes these kind of recommendation cannot provide good impact on the application performance. So you have the golden rule remains to do load testing on your application to be able to validate the performance. So we have seen that we have these kind of 2 approaches, but we still have a number of open questions. So we have this kind of problem, a huge puzzle of services and costs related to that. We have this kind of 2 approaches. One is model-based, but may not be that accurate. The other is load testing based, but it's actually hard to scale this manual load testing approach to the sheer complexity of the cloud options. If you think about today, manual testing process, we will need to try out basically all the different options and the different combination among the storage and the instances to identify what would be the highest performance deployment or our cloud architecture with the least cost. Is still a lot of work, a lot of manual work that would need to be done. Of course, the other key point is that the method needs to capture end-to-end application performance and a unique application behavior, because otherwise we cannot reach our end goal of ensuring end-to-end application performance with the least cost. So based on that actually problem that we just described, we set out to reason about this and try to understand is there a better approach? Can we find a better approach where actually we can completely automate the process and take, in a way, gets the human out of the loop. So remove the human from the involvement of this tedious manual process of trying all the different combinations and tracking the performance, the cost. It's a huge amount of work and can really scale to the complexity that we have today on the cloud, but also on, if you think about all the different other configuration settings that we have on the stack, we have hundreds of parameters that we can use, so it's something that cannot really scale. So we kick off actually a multi-year research effort, and we came out with this new approach, which actually we implemented into the iCommerce product, that is basically considering it is basically using 4 main pillars in order to be implemented. The first one is we need some sort of help from, in a way, in order to being able to scale this approach. Manual approach is no longer working, so we look at AI and machine learning, which is another great breakthrough that we have in the latest year in the IT industry, that is already revolutionizing entire industries. So today AI has reached and even surpassed human performance on certain tasks. So the question for us was, can we really use AI to automate this kind of process and come up with smarter solutions with respect to what the human brain can do? So AI here is the critical ingredient. So there are lots of challenges to be solved in applying traditional AI algorithms to the performance space. One of the first challenges is that you need to be able to actually find good solutions very, very quickly. So we cannot really train an AI model with millions of samples like Google is doing to train neural nets to recognize patterns on YouTube and on the pictures. So we cannot really afford that on the performance space. The other fact is that even evaluating the performance of an IT application is going to take a huge amount of time. It may involve doing 1 hour of performance testing. So it's not something that you can easily. It's not an analytical function that you can easily evaluate, so you change a parameter and you get the value. No, you have to do a performance test. You have to do a test in production to see how the application responds. The other thing that is critical is automation. So it's critical that the AI is not only suggesting what will be the next settings to apply, but the ideal state would be AI is completely orchestrating the process. So it's not only identifying the best settings to try on the system, but it's also applying the setting on the system, and it's actually measuring how the system is performing. So changing the EC2 and EBS storage options to actually understand if we are improving the performance of our application, it's costing less, so it's costing more, and in order to understand how to actually move on toward our goal. Full stack will mean actually to be able to address the whole stack of technologies. Actually, today we are speaking about the cloud, but actually it becomes instantly, when you optimize infrastructure, instantly clear that you need to go above the stack, for example, to understand how the middleware is being configured, how the database is being configured, also the application itself and all the platform like big data needs to be reviewed in order to because also them have lots of parameters that can be tuned. That piece is goal driven. What does it mean is that we can specify the goal to the approach, and the AI will drive our optimization toward higher values for our goal. So in this case, as we are going to see in a moment, our goal would be to maximize the performance and minimize the cost. So AI can work toward improving our goal. So the new vision is actually depicted here. So the idea is that you can recognize in this actually process the typical phases that we go through with manual performance testing. So we do performance tests, we measure the outcomes, we identify the changes, and we reconfigure the environment. The whole this process today is manual. The idea is let's put AI here, so an AI engine that can actually orchestrate whole the process, driven by in order to optimize for a given goal that we can actually specify. So the beauty of that is that the AI is actually the IT system to be optimized is a black box. So you're not gonna need to model in very detail the system that you are gonna optimize, but the AI can learn by doing actual experiments. So it's right to configure the environment, evaluate the changes, and see if the configuration is good and the process continue. Basically, it's an iterative and self-driving optimization. So that's it about the general idea. I wanted to actually present you some results because I think those are actually the most interesting part of the presentation, where we actually apply this kind of process to optimize the price and performance of a real application on the cloud. So the use case was we had an application with a database which was pretty resource hungry, so it was costing a lot on the cloud, and it was suffering a little bit of performance issues. It was a MongoDB database. So the goal for us was let us use Akamas in this case to actually optimize the performance and the price of the MongoDB database hosted on AWS. So the goal that we gave to the tool was minimize price performance, where price is the price of the actual resources on AWS, and performance is actually the throughput of the database, as the database was being able to sustain on a given cloud deployment options on a test environment. So in this scenario, Akamas was actually driving the automated optimization into this test environment. So we already had application load test in place, so we were able to reproduce a realistic workload to drive the application with what is seen on production. And the other interesting thing is that we did, within Akamas, we can support a workflow concept where we can actually identify step by step what Akamas need to do in order to provision, for example, in this case, an AWS environment. So Akamas is selecting the cloud options, for example, EC2 instance type and EBS volumes, but those options are not simply simulated. So they are actually provisioned thanks to the automation that we can build in, also leveraging tools such as Ansible and the cloud APIs to actually implement the kind of architecture that is suggested by the AI engine, and then starting the load test against this environment and measuring what is the outcome. So what are we going to optimize in this, in terms of the scope in this example, are all the cloud options. So in particular, we optimize the EC2, so the instances, and the EBS, the storage. As you get the instances, you get this kind of string, which is representing the kind of instances that you can get on AWS. Let's decode in the string in according to the different kind of actually option that you can select. So the first one is the instant family. C stands for compute optimized. Then you have, for example, M, which is memory optimized, or M, which is general purpose, or R, which is memory optimized. You have lots of choices here. Instant generation 5 is the latest generation. You have also additional capabilities that you can get from the cloud. For example, D stands for storage, that is dedicated to the instance, that is mounted on directly attached to the instance. And then you get the size, which can, for example, which actually influence the number of CPUs and the memory that you get on the VM. As you get the storage, you have three kind of variables you can act upon. Basically, the volume type, so the first type that we have seen before. You can choose, of course, the size, which is of course impacting the cost. And then for certain volume time, you can also select the number of IOPS that your volume will be able to sustain. So in this case, IO1 is this is the kind of storage volume that where you can actually choose the number of IOPS that you want it to be guaranteed. Of course, there are costs related to that, but those are the 7 parameters that we actually used and we modeled within Akamas to being able to actually let Akamas optimize this kind of environment. So I will now switch to the results. So once we build this kind of automation to provision the instances, we model the problem within in order to specify which kind of instances, which kind of storage types we wanna for our optimization. It's time to start the actual optimization, and then it's time to actually wait to see what will come out of the tool thanks to its completely automated optimization. So this is basically the result that we got after. I will have the timeline indicated into the chart. Basically, after a couple of days of completely automated tuning. You can see in this chart there are dots. Each dot is basically a single performance experiment. So you can think of it as a single cycle that we have seen in the chart, in the process chart before. So basically, it's a load test that Akamas drove with a given setting of configurations. So in this case, with a given cloud EC2 and EBS choice. You can see the first point is on the red line, which is the baseline. What for us, the baseline is actually the value of the score, the performance for the price performance for the initial choice where we start from. So in this case, we initially had a R4 large instance on the cloud with a storage type GP2 with 70 gig of storage. The R4 is a typical actually instance type for databases. So we choose that as a typical starting point as we were hosting MongoDB on the cloud. Large means basically 2 CPU and 16 gig of RAM for this kind of starting point. So this is a typical starting point. So what you might choose if you just look at the, in a way, the catalog from your cloud provider, you see you have a database, you have to go to the memory optimize, and you can get this kind of instances. Then we let Akamas play with this kind of huge space of optimization. And for each performance test, we basically record both the performance in terms of throughput and also the price for the given configuration. We normalize, we divide the two, so the final score that each point is getting on this chart is price performance. So we want to minimize price performance. We want to have configuration that have lower price and higher performance. So we are interested in the points that goes below the red line. And you can see very interestingly, that after just about 18 experiments, so it's actually less than 1 day of completely automated tuning, we have found out a configuration that improved price performance by 68%. So it's basically a pretty shocking result also for us to understand that we had this kind of magnitude of improvement that is available today on the cloud. The interesting thing is that, okay, this is an indication of price performance. The next question we had is, okay, what is the price for this point and what is the performance? Because we might have very good results, but we might have much higher prices, for example. So what is the actual price and performance behind this single configuration that we found? Interestingly, actually, we bring into the tool also all the different performance metrics that we care about. So we gave to the tool the goal of minimizing price and performance. But for example, we bring in also the response time that we measure from the load testing tool in order to understand, to have a clear and complete picture about the configuration that we come up with, if it is really good on all the different KPIs that we care about, and potentially avoid situation where the main goal is good, but for example, we are making the application much more slower, which would not be acceptable. So you can see here, this kind of 18 experiment is actually the best configuration that Akamas found. So the score is minus 68%, what we have seen before in the chart. You can see the price here. So in this table, we are comparing basically the baseline price, which is $67.48 per month, actually euros per month, actually, which is the baseline, so the price of our original configuration, considering both the storage and the compute. And the best configuration Akamas found is actually pretty much the same cost. It's 65 euros per month. The other thing that is actually interesting, which is actually bringing down our KPI, is that the throughput. What is happening to the throughput? Of course, in order to have this kind of benefit, if the price is almost the same, we must have an interesting increment in throughput. And in fact, you can see that we went from 2,400, 500 more or less queries per second from the baseline and the configuration to almost 3 times. So 7,600 queries per second was achieved with this kind of configuration. By the way, interestingly, you can see also the latency. This kind of configuration managed to achieve a very substantial also cut in the latency. So basically, the application is 10 times faster with respect to the baseline. So basically, this is the kind of the result that really shocked us to being able to understand that we have this kind of potential improvement where pretty much we improve all the typical KPIs that are where we had to do trade-off. So we improve the throughput, we improve the latency, which are typically in a way one against the other in the performance world, and also we improve a little bit the price. We also, the next question would be, what is the actual configuration that Akamai found? So which kind of AWS services it deployed to reach this kind of settings? So within the tool, after the optimization, we can see actually all the parameters that we have, all the 7 parameters that we have specified, that we have seen before. You can see the baseline values and also the optimal values. So we have modeled these kind of parameters as we have seen before. And from the output of the optimization, we can see that the best configuration that came out of Akamai is to use an M5D large instance. So let's try to understand what does it mean on AWS terms. So you can see here the hardware specification related to this instance. So you can see this in this table. I'm presenting the instance name. So we have both the baseline for large and the new one M5D large. And also a couple of interesting columns, such as the use cases, which is what AWS originally suggests you this instance is good for in terms of application workload. And then you can see how many CPUs, how much memory, and also the kind of storage that is related to this kind of configuration. Interesting, you can see that the first difference is that this kind, the M4M actually instance family is a general purpose instance. So as a starting point, it's not the memory optimized instance that it's typically what people use for databases. So already an interesting difference. Then you can see also the processor difference. So for example, we have a different Xeon processor that is powering the general purpose. Also very interestingly, you can see that this kind of instance have basically half the memory of the original instance. This is again something that shocked us. We double checked several times actually the result to make sure that this is the case. And actually it was the case because it turned out that the database was not benefiting from this all the memory that was originally configured into this instance. So even going with 8 gig was particularly fine for this kind of workload. Of course, this helped also bringing down the cost. The other change is that the instance storage. So you can see actually that this configuration, the D that you can see in the name stands for locally attached storage. So we are not actually, Akamai choose not to, the best configuration that came out was not to use actually the replicated EBS storage, but to use SSDs that are locally attached to the instance, which is another interesting finding because of course those cost less, those are higher performance actually choices. The other step that I wanted to show you is that we went far also and launched another optimization. So for the first optimization that we have just seen, Akamai actually suggested a configuration, the best configuration at least. We have lots of configuration that came out of the optimization, but the best one was using actually locally attached storage, which is, if you think about it, is not ideal from a database perspective because locally attached storage means that if you lose the instance, basically you lose all the data of your databases. So we created a new optimization where we constrained the optimization to avoid instances with local storage and focus on instances with EBS storage, which is actually the standard practice to do databases on AWS. EBS means replicated in different availability regions, so it's much more durable storage. And you can see the result that we got from this new optimization, which is giving us actually much more useful results. So you can see that we have in this table, we have the top 5 configurations. And what I found very, very interesting is the 4th configuration that you can see was able to improve the price performance by almost 33%, so still a significant improvement. And you can see what's happening to the price and to the performance. So basically the price is 24% lower with respect. So we are going from 67 euros per month to 51. And the throughput is actually almost the same or even a little bit better. So again, the new configuration, the best configuration for this particular configuration is actually an instance that you can see here, M5A large, which actually mean if we break down in terms of AWS, you can see that this is particularly interesting because it's completely changed the processor type. So AWS started to offer, I guess last year, these new kind of instances that are equipped with AMD processor Of course, they are not as much aspired as Intel processor, but they are lower price. Of course, the usual disclaimer is that they must be good for your specific workload, so there's a performance difference. But again, for this particular workload, Akamas found out that AMD processors are particularly fine, so we can bring down the cost. And also, again, you can see that 8 gig of RAM was good for this kind of workload, so no need to have a 16 gig of RAM as the original configuration. And you can see that the storage was actually pretty close to what we originally selected, because actually GP2 is the SSDs that are available on AWS, so those are already a good choice for this kind of workload. Yeah, last piece of the presentation was to actually debunk a common myth, which is hopefully explaining why the usual approach of just looking at the infrastructural metrics is not good anymore to ensure application performance. So we were interested in understanding what is happening at the actual throughput of these M5A large, so to the AMD instance, doing the actual load test. So you can see here the actual matrix of the time that we bring into the tool for us to inspect, and for the performance engineer to inspect what is actually happening. And you can see that how does the throughput of the new instance compare against the baseline. So you can see that pretty much it's the 12% higher. You can see it's a little bit more consistent with respect to the baseline. So this is a validation that the performance is actually good. And the other thing that is very interesting is that you can see what is happening at the memory utilization. So we have seen that we had 8 gig of memory instead of 15. And now, actually, we can see that the usage of the memory during the load test is actually pretty much saturated. So both the R4 large, so the baseline is using 15 gig, and the M5A large, so the optimal one is using basically 8 gig. The outcome to understand is that if we would have used the recommendation from the providers, we would have probably got a recommendation to increase the size of the instance, because the memory utilization of the R4 large, our baseline, is pretty much 100%, because this is, again, our databases work. All the memory is get used, so it's not the case that we were using 50% of the memory. The memory is pretty much 100% used, so typical behavior that we see in Linux system. So we would have got the recommendation to increase the actual amount of memory, so buy a bigger instance size for this kind of problem. But instead, Agamas found out that going with a lower instance size can actually improve our price and performance. So let me just conclude basically the talk with summarizing the key results. So the general trend that we are seeing is that the technology landscape is becoming more and more complex. Today we focus on the cloud, but by the way, the same is happening also if you think about the containers, the operating system, the JVM, the big data world. So every layer basically in the stack is becoming more and more complex, and traditional approaches actually are not effective anymore. So we have this kind of approaches that are helpful but cannot really provide the right answer and can scale to the complexities, with the result that we have this kind of opportunities that are left today on the table. So we looked at how AI can actually be used, and is actually very, very helpful also for our domain, so in terms of performance optimization, and can actually reach some kind of unthinkable performance benefits, because I think that doing this kind of work and saving 70% or 40% of price, or at the same time increasing the performance, is something that is very, very hard to do with this kind of complexity by hand, also with our human expertise. Last point that we wanna mention is that we have lots of tools today to help us doing right sizing in the cloud, but it's important to understand that the approach that they are using is not always optimal. So they can actually, as we have seen, suggest configuration that can lead to higher prices, but the performance of the application might not improve due to the fact that they are not actually looking at end-to-end application performance, which is really, really required to reach this kind of benefits. I guess this is it.
All right, awesome. Thank you, Stefan. pack members connected. So I have Rob, I have Bruno Odu, I have Stain,
Exactly.
I have Harry connected, and I have SK. So I don't know if SK is awake or not. All right, so we are all connected. So I think it's a really very hot topic now. I mentioned the cost, and you just mentioned it. Stefano, I had a questions related to because here you took how to pick the right instance depending on the load. And also, I think there's another area where we can optimize, especially when you have elastic architecture. You know, there is some trigger. Are you able to fine tune those triggering mechanism as well?
Sorry, I missed the question. There's been a little interruption. Can you repeat, please?
I was saying that you mentioned how to pick the right instance from let's say if you take a more like a database, which instance will be more adapted to the database in the cloud. And then you can have also a lot of architecture that could scale with the elasticity component. And usually the way it scales, it's related to it could be CPU usage, or it could be throughput. There is different. Do you also can optimize the thresholds that will spin up the instance and deliver the instance in time? Because there's a difference between spinning up there's a machine, but the machine then needs to have the app ready. You can also
yes, in terms of elastic architecture, the typical approach we take is going in a step-by-step fashion. So the first step would be actually optimize the single instance. So it could be just a single clone of your application, or it could be a container, because actually depend also on the application architecture, if it's containerized or it's based on straight VMs. So you can you can do basically the exercise that I've shown with a single, front-end clone, so that you can make sure that this single clone is optimized, and then you have the ability to actually leverage the cost and performance benefits also in a scale-out fashion, so you can isolate the first problem. Then we actually didn't attack the problem of the threshold and the auto-scaling. So these are typical area where actually you have some kind of meaning of model in mind where you can trigger the scaling, but it could be something that it could be interesting to explore. I think the challenge here is to being able to replicate load patterns and so on. But if that could work, I think this could be also an area where we can try. Sure.
So that was the first question I noted down. We have the chance of different pack members. So we'll ask first to Bruno. Bruno, do you have any questions related to Stefano's presentation?
Oh, no, I have no question because I just arrived at the last 5 business slides, so I don't have time to understand all the beginning of the presentation. Sorry, but just to say hello to Steve, like he would like to smile for me. Okay, and so I have no question actually, but I read your presentation and thank you for these details. That's it.
Rob, do you have any questions? I know, Rob, that you're a big consumer of AWS, so I guess the topic was meaningful for you, no?
Yeah, it was. Yeah. One of the questions I had was, apologies, I only saw part of the presentation, but do you increase the load for the bigger machine sizes? How do you choose the right load for the right machine size, if that makes sense?
Yeah, that's a great question. So actually, we didn't change the load across the experiments. So that was one of the original question we had. So how we designed the experiment. So we decided not to it would be an option actually to understand how we can scale. Actually, if by choosing the proper instances, we can also scale, being able to support higher load, perhaps with lower prices. So with this kind of experiment, we actually the load is actually the same across every experiment. So the idea was for this scenario, we have a given business workload. So let's assume that this is what the application needs to do to serve. So we are not going to increase that, and let's find out the best settings for this particular workload.
Yeah, I guess you could always run it again with a bigger workload if you wanted to find out, what if sort of scenarios.
Exactly. So we could, if you are going to expect, the nice thing is that once you have all this kind of automation, so it's a simple change of the load testing script to drive up higher loads, and you start again the optimization. So it's something that can be done. Yes.
Very interesting. Thank you.
I think I'm just going to add one thing. Yeah, just add one thing because someone make a note on chat. So just to mention that the AKMS solution is not only optimizing the cloud instance cost and figure. You can you select what are your requirements, your KPI that you're looking for. It could be the cost, it could be response time, it could be memory usage, and the solution will try to find the best configuration related to your objective. So that's just to answer to Jason's note that has been placed on the chat. Stefano, could you confirm that?
Yeah, sure, exactly. So the focus for this talk was actually about the cloud, which is in a way a newer stuff that we are doing with the product, but exactly. So we already presented in the last pack about optimizing, for example, a database, a NoSQL database, by touching the parameters of the database. So and it's something that can be done even on-prem. Yes.
Harry, do you have any questions to Stefano?
Okay, a quick question, Stefano. One very specifically on the MongoDB. So you spoke about making different changes to the hardware configuration. Just want to validate. So did you have a configured version of MongoDB? There was no configuration changes in the MongoDB, but you changed only the hardware configurations. So
exactly. So we kept exactly. So we kept MongoDB stable with the default configuration, which is we had done prior work to optimize just in MongoDB. So we knew that the original configuration was not the best. Well, we didn't want to actually. So we would have reached a much higher result if we would have optimized also the MongoDB. Yes. So in this particular case, those kind of results are just coming from AWS selection. So pretty much everything else is kept is fixed at pretty much the default values.
Okay.
Bruno, I think you had a question.
Yeah, I'm not sure that my question is pertinent, but it's about Amazon. Imagine that they deliver a new kind of server, a new version of server. Which load is it for you to evaluate this new kind of server? Be sure that it could be useful to evaluate the performance of this new server for your business.
Yeah, sure. So we need, in this case, basically, of course, in general, as a product, we need to stay up to date with the evolution of the technologies and the support. So basically, we need to extend our modeling of the problem. So the kind of parameters, for example, is there a new instance family, we need to model it, and so that AKMS can actually create new kind of instances. So typically, automation or the APIs that is put in place also by the providers, and there are lots of also Ansible and already existing tools that are able to automate the creation of the APIs and so on. So there is lots of work that is typically already done by the community and that is already up to date. And for us, it's pretty easy to leverage that and just instruct the AI engine that there is a new value of the parameter or new range that we want to extend or a new volume type, and it just tries. Because actually this is the advantage of being black box. So we are not going to modeling model the reality that we are going to optimize in a complex way. It's just learning, doing experiments.
Great. I see that Stain is currently playing with Tableau and building nice graphs. Stain, do you have any questions?
Yeah, do you hear me? Too?
Yeah, I can hear you.
Ah, cool. No, I'm always impressed if Stefano is presenting. It's amazing what those guys are doing. And if you listen to what he's saying, sometimes you come with a configuration that, if you think about it, it's so specific that it still optimizes what you're doing. So the devil is really in the detail, and having then automated frameworks that actually come up with the best configuration of whatever you're doing. I've seen this before. It's just amazing. It's like, wow, you let it run overnight. In the morning, you have the perfect conditions. And yeah, I only can congratulate what you're doing. And I look forward to playing with it.
Thank you, Steve.
I don't agree. I don't agree. I mean, my favorite part of load testing was tuning systems. It was fun because you were seeing improvement, and it was funny because you're changing parameters and say, wow, I made some impressive changes. And now it's done. You just killed my favorite part of the job. So I'm not thanking you. You're removing one of the greatest tasks of a performance engineer. Thank you, Stefano. Thank you, Akamas.
No, really, it's not like that because, of course, you need to. It remains to be done several activities in the process. So you can imagine as you are doing this daily, basically all the design, all the load testing, the data, all the stuff that mentioned also Ari for the SAP, how you integrate, how do you ensure, how do you virtualize the services. So basically, you have lots of work to do. And then the nice thing is that once Akamas is running, so you get this kind of insight that is actually still very exciting, because we, as a performance engineers, typically wait for a great result and wait to understand what it did to achieve that. So you have a chance also to learn a great deal about the technology that you are optimizing, and also understanding all this kind of parameters, which kind of impact do they have. So it's also a way, it's not just a black box that you put in place, but it's also a way for you to automate the boring task and understand the potential of improvement that we have in this technology.
And Henrik, you still remember your gaming time. It's like you're playing now against the computer. So you need to beat the framework. So it's even more excited now. So
Exactly. Sometimes we do this kind of challenge. So we had a recent challenge a couple of weeks ago where we optimized a Kubernetes environment. So we actually challenge Akamas in order to understand which could provide the best configuration. So sometimes we do that also. It's funny.
You're doing similar with you're doing the same thing with the game industry. You know, 10 to 15 years ago, when you buy a video games, you were playing during 40 hours, 50 hours. You were just enjoying your game, and now the games are more complex, but now you're playing 5-10 hours and it's finished. So you're just reducing our fun, you know. No, just kidding. All right, so I'm looking at the time. It's almost the 2 p.m., which is the presentation of Bruno. So I'd like to thank you, Stefano, for this awesome presentation. I think a lot of people. Thank you for the session.